secant, tangent, segment, and sector of a circle. After watching this video, you are expected to define and illustrate secants, tangent, segments, and sectors of a circle. Find the areas of the shaded segments and the shaded sectors. Find the measurements of the angles formed by tangents and secants, and value accumulated knowledge as means of new understanding. A secant is a line that intersects a circle at exactly 2 points and contains a chord of a circle. In circle A, notice that line MN passes through circle A at points M and point N. We can say that line MN is a secant line in circle A. Tangent is a line which is coplanar with the circle and intersects it in one and only one point. The point of intersection of the line and the circle is called the point of tangency. In circle E, line JK intersects circle E at point O. Therefore, in circle E, line JK is a tangent line and point O is called the point of tangency. Postulate on tangent line. At a given point on a circle, one and only one line can be drawn that is tangent to the circle. To illustrate, let us consider circle R. If point S is a point on the circle, then one and only one line can be drawn through S that is tangent to the circle. Theorems on tangent line. Number 1. If a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. If line AB is tangent to circle Q at point R, then it is perpendicular to the radius QR. Theorem number 2. If a line is perpendicular to a radius of a circle at its end point that is on the circle, then the line is tangent to the circle. If line CS is perpendicular to radius LT at L, then it is tangent to circle T. Theorem number 3. If two segments from the same exterior point are tangent to a circle, then the two segments are congruent. For example, given line segment DW and line segment GW. If line segment DW and line segment GW are tangent to circle E at point D and point G, then we can say that line segment DW is congruent to line segment GW. A line that is tangent to two circles in the same plane is called a common tangent. There are two types of common tangent, the common internal tangent and the common external tangent. The common internal tangent intersects the segments joining the centers of the two circles. Given circle D and circle E, line C intersects line D, joining the centers of the two circles at point D and point E. Therefore, line C and D are common internal tangents. Common external tangent. Common external tangents do not intersect the segment joining the centers of the circle. Given circle M and circle N, line T is tangent to circle M and circle N. Line S is also tangent to circle M and circle M. They do not intersect the segment joining the centers of the circle. Therefore, line S and T are called common external tangents. Theorems on angles formed by tangents and secants. If two secants intersect in the exterior of a circle, then the measure of the angle formed is 1/2 the positive difference of the measures of the intercepted arcs. Given a circle, In the given circle, line NX and line MY are two secants intersecting outside the circle at point P. Arc XY and arc MN are the two intercepted arcs of angle XPY. Let us now find the measure of angle XPY. So, the measure of angle XPY is equals to 1/2 the measure of arc XY minus the measure of arc MN. For example, if arc XY is equals to 140 degrees and arc MN is equals to 30 degrees, then the measure of angle XPY is equals to 1/2 times 140 minus 30 equals 1/2. So 140 minus 30 is 110. And 1/2 of 110 is 55. Therefore, the measure of angle XPY is equals to 55 degrees. Theorem number 2. If two secants intersect in the interior of a circle, then the measure of an angle formed is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. In the given figure, line WS and line RX are two secants intersecting inside the circle. Arc WR and arc XS are the two intercepted arcs of angle 1, while arc WX and arc RS are the two intercepted arcs of angle 2. Let us first find the measure of angle 1. The measure of angle 1 is equals to 1/2 the sum of its two intercepted arc, the measure of arc WR plus the measure of arc XS. For example, if the measure of arc WR is equals to 100 degrees and the measure of arc XS is equals to 120 degrees, therefore, the measure of angle 1 is equals to 1/2. Let us add 100 plus 120. So, it is 220. And 1/2 of 220 is 110. Therefore, the measure of angle 1 is equals to 110 degrees. Let us now find the measure of angle 2. So the intercepted arcs of angle 2 are arc WX and arc RS. For example, if the measure of arc WX is equals to 80 degrees and the measure of arc RS is equals to 60 degrees, therefore the measure of angle 2 is equals to 1/2 the measure of its intercepted arcs, which is the measure of arc WX and the measure of arc RS. Now, the measure of angle 2 is equals to 1/2 80 plus 60. 80 plus 60 is equals to 140. And 1/2 of 140 is equals to 70. Therefore, the measure of angle 2 is equals to 70 degrees. Theorem number 3. If a secant and a tangent intersect at the point of tangent C, then the measure of each angle formed is 1/2 the measure of its intercepted arc. In the figure, line QS is a secant and line RW is a tangent intersecting at point S. Point S is the point of tangent C. RQS is the intercepted arc of angle QSR, while arc QTS is the intercepted arc of angle QSW. Let us find first the measure of angle QSR. The measure of angle QSR is equals to 1/2 the measure of RQS. For example, if the measure of RQS is equals to 170, then the measure of angle QSR is equals to 1/2 times 170, or 1/2 of 170 is 85. Therefore, the measure of angle QSR is equals to 85 degrees. Now, how about the measure of angle QSW? To find the measure of angle QSW, the measure of angle QSW is equals to 1/2 the measure of arc QTS. For example, if the measure of arc QTS is equals to 190 degrees, then the measure of angle QSW is equals to 1/2 of 190, and 1/2 of 190 is 95. Therefore, the measure of angle QSW is equals to 95 degrees. The region bounded by an arc of the circle. So let us name this as arc AB. And the two radii to the endpoints of the arc. So we have radius AC and radius BC. So the region bounded by an arc of the circle and the two radii to the endpoints of the arc is called the sector of a circle. To find the area of a sector, first step is to find or determine the first ratio of measure of the arc and 360, or get the measure of the arc and divide it by 360. Second step, find the area of the circle. So the formula for finding the area of the circle is equals to pi times the square of the radius. Then after that, find the product of step 1 and step 2. Example, if the given radius of the circle is 10 centimeters and the measure of arc AB is equals to 60 degrees, let us find the area of sector ACB. So, number 1, the measure of the arc, which is arc AB, is 60. Divide it by 360. So, it is equals to 1 over 6. So, yan yung sagot natin sa number 1. Step 2, find the area of the circle. So, the formula is pi times the square of the radius. So, area is equals to pi. The given radius is 10. So, 10 centimeters raised to the second power. The area is equals to pi times 100 square centimeters. Therefore, the area of the circle is 100 pi square centimeters. Step 3, multiply the two. So the area of sector ACB is equals to 1/6 times 100 pi square centimeters equals 50 pi over 3 square centimeters. Therefore, the area of sector ACB is 50 pi over 3 square centimeters. A segment of a circle is the region bounded by an arc and the segment joining its endpoints. To find the area of the segment, subtract the area of the triangle from the area of the sector. For example, if the measure of arc PQ is equals to 90 and the given radius is 5 centimeters, find the area of the shaded segment. Solution. Let us first find the area of triangle PTQ. The formula for finding the area of a triangle is equals to 1/2 base times height. Based on the figure, ang base natin ay yung radius na TQ, which is 5 cm, at ang height niya ay yung radius PT, which is also 5 cm. So the area of the triangle is 1/2 5 centimeters times 5 centimeters, or the area is equals to 25 over 2 square centimeters. Then let us now find the area of sector PTQ. So kunin natin ang measurement ng arc PQ, which is 90 degrees, divided by 360 and multiply it by the area of the circle, which is pi times the square of the radius, 5 square centimeters. So let us simplify. 90 over 360 when you reduce to lowest term is 1/4. Pi is equivalent to 3.1416. So gamitin muna natin yung up to 2 decimal places, which is 3.14. Then 5 cm square is equals to 25 square centimeters. So simplify, we have 19.625 square centimeters. Now let us find the area of the segment of a circle. Subtract the area of the triangle from the area of this sector. So the area of the segment is equals to 19.625 square centimeters minus the area of the triangle, which is 25 over 2 square centimeters. Let us simplify first. 25 over 2, it is equals to 12.5 square centimeters. So therefore, the area of the segment is equals to 19.625 square centimeters minus 12.5 square centimeters, which is approximately 7.125 square centimeters. We're done. You are now ready to answer your module. Follow carefully the instructions indicated in every page.